In this video, I am going to demonstrate how to use uniTank to create shell layouts manually and automatically. If you haven't done so yet, you should watch the tutorial that demonstrates how to create floor layouts, as many of the same ideas are covered in that video. With that said, this video will move at a quicker pace with the assumption that you understand the basic ideas of creating layouts. This part of tank analysis comes after you have completed the shell analysis, because we will use the outputs from this analysis to visually aid us in finding shell courses and plates. When creating shell layouts, you need to be in cylindrical mode. Make sure that the diameter in the settings is set properly so that the view center is focused on the shell. So first off, I will load in some of the outputs from the shell analysis. The three that I typically choose is the alignment, intensity, and standard deviation. I am going to use the alignment extrema model because it is mostly grayscale. In the floor layout tutorial, I explained what the main differences of these models are. I am going to first demonstrate the manual tools because you may need these to repair the results from the automatic tools. So first off, I will add shell courses. There are two ways I can do this. First, I can specify shell courses manually, and uniTank will repeat these course heights until the shell top. If I enter different course heights, uniTank will repeat the last value for the remaining courses. If you set the courses this way, any existing course definitions will be deleted. The other way I can define courses is by specifying points at each course height, then adding shell courses that way. If you need to set a course at an exact elevation, you can do this by setting your elevation using the Go To feature. Looking from top view, drop a course point at this elevation. Once this is completed, I can go and identify the shell plates. Again, I can do this in two ways. The first is to identify every single plate in a course. Alternatively, I can identify a single plate line per course and get uniTank to place plates at defined whole plate intervals. Lastly, if you have additional items to delineate, such as repads or patch plates, you can use the polygon, circle, or rectangle tools to delineate them. Then you can create them as shell outlines. Now you know how to use all the manual shell layout tools, we will see how we can do this automatically. In the floor layout video, I go through the various parameters in the automatic detection tool dialog, so I won't go through them again in this video. So I'm going to use the detection tool to find the shell courses. If the tank has a floating roof, there's a good chance that one of the shell courses is in the floating roof shadow. If this is the case, you will have to add the course manually using the point method. Don't define it using the course height method, because that will delete the other auto-detected courses. Next, we will find the shell plates. The shell plates are more difficult to locate because they are butt welded. That means we need to rely solely on the geometries. as the standard deviations will not illuminate these well. You may need to play around with the options to get the best initial estimate, but more than likely, you will have to use the local detection method to find all the plates. Once you are satisfied with your layouts, create the plates. You can use either numerical numbering or coarse plate style numbering. Finally, output the plates to a graph, CAD-compatible DXF files, or Excel-compatible CSV files. uniTank will automatically calculate plate location and dimensions for you.